Yeah, I was actually talking about that with a friend who's like not technical at all, but he sent me this article on kind of the future of programming and programming bugs, like where it's going to evolve. And even though I was like just talking about money, at the end of the day, you break something in billing software or whatever, it's not a life or death situation. But like with the advent of like self-driving cars and things like that, like all of a sudden bugs start to matter like a lot. And
Yeah.
I mean, I was thinking like I know even the best software that we build is like riddled with bugs, so it's kind of interesting to think about how those are going to play out in some of these like really complicated systems.
Hi.
Hey,
How are you?
I'm good, thanks. How are you?
Good. How did you like this conference so far?
It's been great. It's my first time in Budapest.
Yeah?
It's the third conference I've given a talk at.
Okay.
So it's been a fun experience.
Okay. And did you have nice feedbacks?
Yeah, I always like to put a couple of jokes into the conference, and
Yeah?
they landed pretty well, so that's fun. But it's funny because the last time I gave a talk, it was on service-oriented architecture.
Okay.
Really generating a good service-oriented architecture with your Rails app. And this one is kind of about the effects of going to service-oriented architecture and the kind of downside. So now that I have a little bit more experience with it,
Okay.
I realize the pitfalls.
It's actually a trend that I've been seeing lately, that like 3 or 4 years ago, a general talk about microservices or service-oriented architecture would be mostly about, oh, how awesome this is, and this is going to solve all your problems, and that's cool and great and all that kind of stuff. And then now we are starting to get into like this more productive mode where we're already talking about the problems.
I mean, microservices, like I think that trend is still going on. Like microservices take it to the next level, where everything is this like separate thing. And I think a lot of people have realized the productivity hit that they get, just because you have to do all these retries and networking issues that you get with the microservices and the communication. But I always felt there's like this missing thing that people don't see when they move to this like service-oriented or distributed architecture, and that's kind of the data inconsistencies you get, and that's kind of what my talk was about.
Okay, and was there any real issues that you ran into that generated that?
Yeah, actually, so I work on the billing team at DigitalOcean, and when I started the month close pipeline that we do, and that where we like invoice users and kind of charge them, that was all synchronous.
Okay.
And we moved it to kind of this like asynchronous pipeline and heavily using Sidekick workers. And when we did that, we ran into a whole host of different issues. And one of them in particular sticks out to me because that was the example I gave in the talk. But we were double charging a lot of users 1 month because they would come in, they would get an email from us saying that their payment was made, and they would come in or that their invoice was generated, and they would come in and make the payment themselves. And then later we would charge them automatically anyway, so they'd get double charged.
Oh.
And that's because we moved to this pipeline approach, where we would generate their invoice and then batch off a bunch of jobs in the background, like their payment job and their an email job and all these different like background workers, so we could really scale it nicely. And that didn't account for the fact that like by the time those workers run, something changes in the environment, right? And what work it was supposed to do doesn't necessarily apply anymore. So that in that example, we enqueued a payment worker to say like charge this user $10 or whatever it was. And even though they came in and paid, it still charged them because it was in the queue. So that was kind of like the example that stuck out in my mind. But in general, there's like this concept that I started to like realize where when you have this like these distributed jobs like this, these background jobs, you have to assume your environment's going to change over time,
Absolutely.
right? Like from the time you enqueue the job to when it runs, the environment's going to change. Like reality at one point is going to be different from reality at another.
And that's actually related to the ACID guarantees that SQL used to have, right?
Yeah.
So all of us have been, well, most of us who have been around in the industry for like at least 10 years have had that nice world where you had like a single SQL database, and then you didn't have to worry about that kind of consistency
Yeah,
issues.
exactly. And that's kind of interesting because I feel like there was this period where people went to these NoSQL databases that kind of lost those consistencies, and I think they're starting to pull back from that a little bit, like realizing, hey, you know, these ACID guarantees are really awesome. And I think that kind of maybe applies to service-oriented architecture. Like, kind of one of the points I was making is that you should embrace this inconsistency if that's what you want, but if you need that guarantee, then that's not the right approach for you, right? Like, if you need consistency, go with a system you can guarantee is consistent. And like same with databases, if you need it, don't try to like fit a database that's not going to do what you need it to do. Right?
Absolutely.
So.
I mean, I personally think that these NoSQL databases can be really useful in many cases, especially when you have a large system and you have no chance for consistency anyway.
Right.
Because, I mean, if you have microservices, then you are giving up on consistency anyway. So why not give it up even at the database level?
Right.
If you don't have it anyways. So you have to concentrate on that in some other way, or solve those problems in some other way.
Yeah, and that's where I think eventual consistency becomes really important, and that's kind of like where you work under the assumption that your systems will tend towards getting some kind of consistent, but you can't assume that they're consistent at every point in time.
Yeah.
And what surprised me is that actually telecom billing, like this legacy telecom billing from these like telecommunication giant, they're like pioneers almost in eventual consistency, and there's a lot, because I work in billing, like we studied a bunch of different billing models, and I was surprised to learn that these like really old systems from like the 60s and 70s have kind of pioneered this eventual consistency, because telecom billing apparently is very complex, and they have been working towards that for a while. So
that's interesting. And how did you deal with error cases? I mean, when you have like a microservice architecture, you will end up with codes that are not successful.
Yeah.
So you have to deal with that somehow. What was your approach?
Well, that's why we kind of make heavy use of background workers on the billing team. We use Sidekick in particular, but there's like a bunch of awesome ones for Ruby. There's Rescue and Delay Job and Sidekick. And the nice thing is if you kind of move all your services into these background workers, they kind of they're built to expect failure. So when we moved our synchronous pipeline into this asynchronous background worker, and we queued this like payment worker, if it failed because Stripe was down or something, and we got like this network issue, we would automatically retry in like 5 seconds or something like that. So you kind of had that built-in failure recovery by going to these background workers, and that's really awesome, because we encounter that a lot, especially even like with our internal APIs or external APIs or whatever it is. We encounter those error conditions a lot, and it's nice not to have to be like, oh, something went down, like now our systems are like out of whack, like we have to go in and do some like manual data cleanup, because the system is built to expect failure because of its asynchronous nature. Like you get that automatic recovery. Your system is like resilient to the failures. So it's kind of nice.
But one thing so actually we had very similar issues. We have been sending emails from an automated system, and you basically can build up a workflow, and then you can say that whenever someone is in this step of the workflow, they should get an email. And the thing that we realized was that it's really important to make sure when you retry something, and it already happened, because it happened just the calling part, it didn't get the response. Then you have to make sure that you don't deliver that email twice.
Yeah, idempotency is actually a huge thing for us. That was one of the reasons we split up this pipeline, because it did a bunch of things at once. Like it generated the invoice, it made a payment attempt, it like sent the email. If something failed halfway through and we redid all those jobs, like who knows what's going to happen? Like, is it idempotent? We don't know. When you kind of minimize the surface area one worker is doing, you kind of have more of a idempotency guarantee. Like if a payment fails, then we can retry it and like not worry that other stuff is going to be done. So there's that piece, but then there's like the payment itself. Like sometimes we did actually have issues where the payment attempt would say it failed, but it didn't, and then we'd retry it and you get double payment.
Oh yeah.
And that's where like you need additional idempotency keys. So like these critical jobs like payments, we actually have additional idempotency checks around them.
Yeah.
So what I actually like Redis, the mutex, Redis mutexes, you can kind of like lock this key or like use a key for a unique job, and then lock it, and then if it fails, it will release it, or if it succeeds, it releases it. If it doesn't, it won't. So that kind of helps prevent that.
So that's actually really similar to what we did. We didn't use Redis, we used SQL, and then actually we put every operation in like a transaction. So that
we use that too. So
so that's one way. And another interesting thing that I came across was an interesting case. I have this workshop called Lean Poker, and what it does is basically you have like teams competing in writing poker bots. That's just the and what happened there is that whenever I requested the gameplay from one service to the other, and that game didn't play in time or it just failed, then I had to do something about it. And the interesting part is that their retrying would have been like disaster, because then you would have like games that are not coming in for minutes and minutes and minutes. So what I actually did there, and I think that's also a valid option in some cases, where if you cannot do something in time, you just don't do it. You just say this is gone, and you just revert everything that came before.
Yeah, I think that's kind of a good approach to take. Like, I think that's something that you want to consider whether it's needed in the workflow that you're doing. But I also think it's a good idea sometimes to just say, hey, we're bailing out. We're like going back and doing nothing. And some of the checks that we have in our system now kind of do something similar. Like it checks for a mismatch of conditions. Like our payment worker, for example, will check if the amount it's looking to charge is equal to the user's current balance, and if it's not, it bails. We can do other things, but we're like checking that the assumptions that we made are the same as the current environment. So, and if they're not, then we say, hey, we're not going to do anything. Like, we'll deal with this another way. And we have like reconciliation systems that go back later that like catch those missed cases. So that's like one way to do it. Another is to like kind of roll back everything, like you mentioned, and start from like square one. So.
Yeah. So you are working in Ruby right now.
Yep.
Have you ever always been working in Ruby, or this kind of a switch?
Yeah, I've been pretty much primarily on Ruby for 6-7 years now. And when I started, it was my first job out the gate was Ruby. So it was like the first language I learned, and I kind of fell in love with it.
Yeah, it's a beautiful language. I can agree to that.
yeah, and actually, right now at DigitalOcean, we're kind of switching more to Go.
Okay.
About like half of our code is in Ruby, but like all the new stuff is mostly in Go.
Do you like Go?
I like some things about it, but coming from Ruby, it just feels like very verbose to me. Like I'm always writing things, and I'm like, this would be like one line in Ruby, like one like very expressive line, like it would be easily readable. But like in Go, it's like 20 lines, and I'm like, oh, come on. But Go, it gives like some nice things, like the type checking is nice. I do kind of appreciate having that. And Go is like a very simple language to learn. But I think I'll always kind of like going to Ruby first for small projects. It's just so easy to.
Yeah, I mean, I actually didn't use Go so far. I did check on it a few times, like playing around with it, but I didn't use it in production. But I personally didn't like it. I kind of felt that it has like some bad patterns in them, like like when you're returning success value, and then you have to use output parameters passed in by reference. That's like a big no-no to be.
I mean, I think the multiple return. When I was like before I started programming professionally, I was always like, hey, I wish I could do multiple return because I want to return like these two things. And as I started like gaining knowledge professionally, I realized that was kind of not always the best approach. And now Go has it, and I realized, I really don't like it that much. Like, in Ruby, like if I wanted that, I'd put together like a struct or something and return the struct with the methods on it, and I think that's cleaner. And that kind of leads to some of the verbosity that Go requires, is because now if you have a multiple return function, you can't easily compose functions because they might have multiple return arguments. So like it's littered with this like if success equals nil or if error equals nil.
There was a really nice post on, I think on Reddit or something like this, where they so the premise was that what if programming languages were weapons?
Oh, yeah.
And then it went through, and Ruby was this amazingly beautiful sword, and it's great, but it's a bit clumsy to fight with. And then there was Go, which was a gun that you always have to check if it fires.
Yeah, sounds about right.
So that's I think that sums it up really well. What my core problem with Go was when I actually tried playing around with it.
Yeah.
But actually, I think that I didn't get to the parts that are good, because I just played around. So people say that it's really good for concurrency and stuff like that. I didn't get there, so probably that's part of the reason why I didn't like it.
Yeah. I think with Ruby, I've come to love it more as I've used it more. And as like when I first started, like the first 4 years, it was also mostly in Rails too, and I really liked Rails, but I haven't actually used Rails in a couple of years now, and I've been mostly using like Sinatra and other kind of other frameworks. And if anything, that's more. I have more appreciation for Ruby now, because it's like, and the Rails and the Ruby ecosystem, because you can do so much with so little. And it's just so dead simple to like put together a quick little app or like a service, or write some kind of class, like a service class to do one thing.
Yeah, I mean, the real advantage of Ruby is its expressiveness, but also its downside, because I mean, if you have that many options to do things, then it also enables you to, well, just hack. And then if you have like a bunch of junior developers in Ruby, that's probably not the best idea.
Yeah, I think it's a shame that so many people just, their only experiences with Rails, because I think Rails is great, but like there's more to it than Rails. Like you get stuck in this Rails ecosystem, and you kind of like bogged down. I know people who wouldn't really know the distinction between Ruby and Rails. Like they would try to write Ruby and use like Rails active support methods, because they didn't know that, like where the two were different, right? Yeah. Because they were like always stuck in this Rails ecosystem. So
I actually didn't use Rails much as well. I kind of got started with Sinatra when I first dipped my toe into Ruby, and then I stuck with it because I really liked its simplicity, and that it didn't try to consume my application. I mean, most frameworks you would have like the situation where the application is so grown together with the framework that you can't even use the functions without having to start up the entire application.
Yeah.
Which is also not so good when you're trying to do testing.
Yeah, exactly. I think that it works pretty good for big teams because it kind of enforces some of these patterns. But if you have a smaller team, I don't think Rails is necessarily the best place to start because you don't need so much of that overhead, really.
Which talk did you like the most today?
Let's see. There were a couple of good ones. I'm actually a physics major by education, so like I never started programming out the gate, like just out of interest. So I did a lot of like heavy math stuff, and there was actually a talk today on TensorFlow, which is like this Ruby library on doing tensors and it's kind of this machine.
Is it a port from the Python TensorFlow library?
Yeah, so it's
it's just a wrapper around the Python.
It's kind of a wrapper on the C bindings for. But apparently, this like TensorFlow library is ported to pretty much every platform out there.
Okay.
But it was cool because I enjoy that like heavy math component to it. Like there was an example of like modeling the stress on a physical object using this TensorFlow, and the geek in me loved that because I know all the math behind it. So I really appreciate that for like its just pure technical nature, and there were cool examples too, like using it for machine learning and like picture identification. One of the examples was a picture of a dog, and using this TensorFlow library, they were able to identify the breed of the dog. Just using kind of the machine learning API that it gives you.
Yeah, I mean TensorFlow. I use Keras, which is a wrapper around TensorFlow in Python, and it's really awesome for like doing these really simple deep learning models. And you actually, because there is this stereotype that for machine learning you have to be like a real math-heavy person, and with Keras you can actually build these things without having much of a mathematical background, which I find really interesting. By the way, I'm a mathematics major.
Oh, really?
Yeah, so I actually switched from math to computer science or more like programming for my PhD. And yeah, so I mean, for me, it was really interesting to see that with these newer libraries now, people are starting to work with these machine learning models without having like this deep knowledge.
Yeah, I think that's going to become more common now.
Especially because you need it. I mean, a lot of the things or innovations that have been around in the last few years were in AI.
Yeah, exactly. Looking to predict like user behavior or ways to like make the user's experience easier. So you have to start moving to this kind of predictive model for certain things.
And so you said that you were a physics major. How did you get into programming then?
Yeah, it's interesting because I was actually in a PhD program for physics, actually applied mathematics, which is kind of between math and physics. And it had like a big lab component, so I had to like go in the lab every day and take these like samples of like really thin aluminum and like process them and go under this big hood in the lab and do all this stuff. And I hated that part because I was like clumsy and it would always like mess up the samples. But the second part of that was like creating these models of what you expected to happen and then like modeling them on a computer. And that involved like programming the model into the computer, either using like MATLAB or Python or something. And I always found that was the part I loved the most. It was like fun to me to like kind of translate that model into an actual program. So I was like, well, I mean, I don't love the lab part, but I love this part. Maybe I should just concentrate on this part. So I actually left graduate school in the middle of the PhD program to take a job in.
And what was your first job?
I worked at Epic. It's this software, this healthcare software company. So they build electronic medical records. Okay. And then eventually I kind of moved out west and joined like the ecosystem in San Francisco. because that's kind of where everything was happening. And then ever since, I've kind of been doing Ruby, doing web development, and I love it. I think there's so many possibilities. Yeah, I've been working on billing systems, not just at DO, but my last company, and then even at Epic, I was kind of on the like scheduling and billing team. So I've been basically in the billing domain for a long time. And you kind of run into the same set of problems, like payments always, like preventing duplicate payments is always a big thing. And there's just like a certain set of problems that always comes up. So I feel like a lot of developers I know don't love working in billing because it's not necessarily sexy, and a lot of them are scared to work on billing because you're dealing with people's money. And if you make an error, you kind of like you're either overcharging people or costing the company. You're costing someone money, the company, the user. But the more I've kind of worked on it, the more I kind of like it because it's like a very tangible domain. Like people understand money, right? People know what it is, and it's important, even if it's not always like the coolest thing. But like it's important because people care about money, right? So.
Yeah, actually, it's interesting because I have this story. I'm not sure if you remember the movie Sully. The one where the pilot
airplane?
He actually landed on the Hudson River.
Yeah.
And when we actually left the theater, my wife said that she would never work like an air traffic controller because it's a responsible position, and she said she would never work in a position like that because it's super scary. And then I caught her attention that to the fact that she was the developer working on stuff that if that thing breaks, then people are in trouble because, not in life or death situation, but she was actually working at Prezi at the time. And if in the middle of your presentation, the presentation software breaks, that's like really annoying.
Yeah.
So I think most positions in IT are like that, and you have like this enormous responsibility on you. Yeah,
I was actually talking about that with a friend who's like not technical at all, but he sent me this article on kind of the future of programming and programming bugs, like where it's going to evolve. And even though I was like just talking about money, at the end of the day, you break something in billing software or whatever, it's not a life or death situation. But like with the advent of like self-driving cars and things like that, like all of a sudden bugs start to matter like a lot. And I mean, I was thinking like I know even the best software that we build is like riddled with bugs, so it's kind of interesting to think about how those are going to play out in some of these like really complicated systems.
Yeah, and with AI, it's getting even more interesting because there you don't actually know what's going on inside your algorithm. It's more like something, it learns what to do, but you don't know how it does it. And because of that, it's really, really hard to actually figure out what is the problem.
Yeah, I can only imagine debugging a system like that where there's not like this thing that you can inspect and reason about.
Thank you for watching this episode. I hope it earned your subscription. But while you're here, let me show you something. The people behind me are playing a game called Lean Poker. It's a fun and exciting way to learn how you can deliver value much faster than you have ever imagined. It's exciting. The link is in the description. Check it out if you want to support this channel.